So this is week 14. So the agenda we have today, we're going to finish the example we did on Friday. Okay, so we are going to complete example on Tresca criteria. Then we are going into hormesis. Okay, hormesis criteria. So it's the energy criteria that we are going to do with hormesis. So last week, we finished off with this expression of, or what did we do? So we are dealing with this example over here, right? We want to determine the required diameter of the shaft using the maximum shear stress theory. Okay, so what we did is we have to identify the element where failure occur. Just to recap quickly, then we construct our 3D mold circle. Then we come out with an expression, or we know that our XY plane, exact plane, the plane is the largest diameter. Then we use this expression over here. Then we start deriving radius of the circle, stress max and stress mean. And then a student told me, Eugene, isn't it true that the final expression over here, right? This expression over here, right? So if I were to go further, right? So if I were to write this as 50 times 10 to the power 6, this will be equal to this expression over here. Okay. Right. And you realize that this expression over here and this expression on the radius of the circle, which is our tau max, are the same. Okay. And it's right. You can use it. Okay. But we have to be careful because later on, I'm going to tell you why we have to be cautious. Okay. When this condition will work and when this condition will not work. How many of you are doing numerical methods now? One. Okay. So there's a few of you doing numerical methods. The rest of you have not. It's fine. So next, we are going to solve this expression over here. Okay, we're going to solve. Okay, so I'm going to, there are two ways that you can solve this. Okay, so example, continue. So what we do, there's, I beg your pardon, there's a square over here. I think my square is missing on the other one also here. Is there a square? Yep. Can you put back the square over here? Okay, there's a square over here. And I was hungry that day, I think. Okay, there's square over there. So if I were to, I'm not going to do too much. I'm going to skip some steps. Okay. So what you have over here, okay, so you will have, I'm going to put this back as 100, and I'm going to put the 2 back here. Okay, I will not transfer across. I'm just proving the point that can use the tau max equation. So once you have, wait, is it 50 times 10? Hold on, let me look at the value. I might have mistake some value. Hold on. Hey. times 10 to the power 3. I got it wrong. Okay. So from here, what I'm going to do is I'm going to get rid of the 2 by introducing the 2 into the term and put the 100 times 10 to the power 3. I'm going to square it. So what we have over here is minus 2500C minus 70. Okay, then divide. Because I put the 2 back in, you get pi c cubed, and this whole thing squared, plus by 4 times over here, 55200 over pi c cubed squared. Okay. And then when we expand the term, okay, what we will get, I'll write the next step for you. Is a bit long, okay, but I'll write it down. I will bring over the pi squared and C6, okay, because the denominators are the same. So this will be equal to 6.25 times 10 to the power 6 C squared, then plus by 360 times 10 to the power 6 C, and then plus by 5.184 times 10 to the power 9, and plus 12.188 times 10 to the power 9. So what I did over here is I just bring the denominator cross over here and I expand the term. And finally, you will have this expression over here is 10 times 10 to the power 9 pi squared C6. And then you will have minus 6.25 times 10 to the power 6 C squared. And then you're going to have minus 360 times 10 to the power 6C. And then the 5.184, you can add with the 12.188, you will get minus 17.732 times 10 to the power 3 is equal to 0. Okay, so to solve this is times 10 to the power 9, I beg your pardon. Okay, so you can get rid of times 10 to the power 6. So this is 10 times 10 to the power 3 pi squared C6 minus by 6.25 C squared minus 360C minus 17.732 times 10 to the power 3. The whole thing is equal to 0. So we have to solve this expression over here. Okay, can you remember how to do it? Yes or no? So how many of you forgot how to use your calculator? Can you still remember or no? No? Okay, I'll show it to you. Okay. So we just use the calculator, but the calculator answer is wrong. I have no choice. I have to accept your wrong answer. Okay, the calculator answer will be wrong. Okay, good. This time it's working. You can see pretty well. Yes or no? Okay, so I'm going to. So I want you to see. Can I do this? Can you see the side monitor? Yes or no? Right. So if you look at the side monitor, I'm going to enter those numbers. Okay. So first you turn on. Unfortunately, this cannot be recorded. Okay. And then I do shift clear all. So the first one is what? 10 to the power 3. 10 to the power 3 times by pi squared times by shift pi squared. And then times by C. So C is you times by alpha, I call it A. Okay, so alpha, can you see the sign? You can see, right? Where is A, right? Then power of 6. Then minus by 6.25 times by, again, A squared minus by 360 times by shift A minus by 17 point what? 732 of 3. And then the equal is alpha solve and 0. Okay. So the next thing you do, you press shift solve twice. Okay. So shift solve once, solve for A, yeah, shift solve twice, and we just wait. In the exam, I will accept your calculator's answer. Okay. So the answer is equal to what? Can you see for me, please? So C is equal to what? Minus by what? 0.7492. Minus 0.74. Do you all get that? Yes or no? 93. Okay. Or 9 inches or 93 inches. Okay. Now this answer, coming back to here, you all have any questions using the solver and the calculator, or we're good to go? We're okay? So those of you who have taken 2Q with me before, we use it. 3A, we use it. Numerical methods, you can also use it, but you have to be really, really what? Careful. So what's the problem with the answer over here? Anyone? Wait, what's the problem with this answer over here? It is what? Negative. But in the exam time, I will accept this answer. Are we clear? Okay. So in exam time, you are going to tell me radius is going to be equal to 0.7493, and the diameter will be equal to 0.7493 inches is equal to 1.4986 inches. Okay, that is the value we get. Now, I'm going to show you how to get the true answer. Okay, unfortunately, to get the true answer, you need a computer. Okay, and I don't want you to just know this topic just because you have to sit for your exam. I want you to know this topic so that you can actually apply what you learn in industry when you are required to do this, okay? So what we are going to do next, just to sidetrack a bit, we're going to use Excel. Okay? Excel can solve this. Two methods, okay? And I think it's good that you learn, and this is recorded. And whenever I find it real useful, because up to today, when I'm doing my research, I still do the same thing. Okay, I apply these two. So on Excel, so this is your Excel. So on your Excel, you go to data, you go there, and there's a solver. Okay, so you have to, the solver is inbuilt into your Excel, and you have to upload it. To upload it, you go to File, you go to Option, and you go to Add-ins. Okay, Add-ins, solver. Can you all see solver add-in? Yes or no? Right? Go to solver add-in, just click OK, and then boom, boom. Okay, it will upload everything. Are we clear? Okay, so use the solver. So there are two ways that we're going to solve this. So the first way that I'm going to solve this, hold on, let me make it in such a way that you can see this better, I hope. Okay, because this is not so clear now. If I could do this at, why not? Yeah, better now, better. Can you see it better now? Better? Better. Okay. So what we have to do now is we have to enter those values now on Excel. Okay. So this is the values that we have. So on Excel, hey, come on, Eugene. Don't screw up. Okay, so we are going to enter this equation. So we are, the first thing we're going to do is I'm going to use the go seek method.